Hello, everybody, and welcome to your official first lecture on the engine performance overview. So let's get started here right away. And what we're going to do is we're going to go ahead and go over the first section of the engine performance overview. I hope that you guys have had a chance to go ahead and start on your worksheets and have also completed the pre-test. Those need to get done as soon as possible. And this lecture will help complement your worksheets, okay? The pretest, remember the pretest and the worksheets. The pretest is just that. It's just to find out where we're at, find out what we're lacking, and maybe some of the things that we need to brush up on, especially electrical. I feel that a lot of you might come into this course and have maybe taken electrical 2 semesters ago, or even engines two semesters ago. So some of the basics are not lost, but just kind of put back in the back shelf somewhere, okay? So hopefully this will give us a nice introduction and kind of help us to remember some of the skills that we gained during electrical and engine class. Remember that this class does require that you have passed your electrical and engine course, so it's heavy on those two areas, in those two areas, okay? So what else? Besides that, we're going to go ahead and look at this presentation. And actually, before I do that, I want to talk about a little bit about engine performance and what we're going to be looking at. Okay, so I'm going to go ahead and switch over here to another device so that I can give you kind of a whiteboard, feel on it. And let me see here. Should get us going. Okay, and let's see here. There we go. So you should be seeing a whiteboard, okay? And first of all, we're going to talk about engine performance. Okay, so engine performance, there's misconception about what engine performance is. I've reviewed some of your contracts, and I've noticed that some of you might have a slightly different idea of what engine performance is and what's going to happen in this course. So basically, what I want to describe engine performance is basically to get the engine back to as close as it was in when it was new, okay? Because an engine, an automobile engine and computer control system and fuel system, all that tied together should run just as well as it did from day one up until it has quite a bit of miles on it. Today's engines easily last into the 200,000s. That without too much of a dilemma. Back in the 60s, 70s, 80s, if a vehicle ran to 100,000 miles, that was considered the end of the engine's life. Today, when we're cresting close to 100,000, we still feel that engine is in very, very good condition. Okay, so a lot of things have changed as far as engine performance, but what I want to talk about about engine performance is something called the engine performance triangle. Okay, so the engine performance triangle, if we think about it just like a triangle, if we draw a triangle like so, okay, we notice we have 3 sides, we have 3 equal sides, and it doesn't matter which side you pick for which component, but for each of these sides, you're gonna have something. First of all, we'll start over here, and we'll call this corner the air fuel corner. So one of the requirements is going to be the air and fuel, okay? And when we talk about air and fuel, we talk about something called the air fuel ratio, okay? That is what part to what part, okay, is required. So for air fuel, we're looking at a ratio of exactly 14.7 to 1. That being 14.7 parts of air to 1 part of fuel, okay? And remember that that's by weight, okay? By weight, not by volume, but by weight. And we'll talk about the difference of that later, okay? During this presentation, you're gonna hear me say that a lot. We're gonna talk about that later. We're gonna talk about that later, because if we dive into just this one section of air fuel, we'll be here for hours, okay? So just remember that one of the corners of the engine performance triangle, okay, and I'll write that up here, okay. Excuse this, this is the only type of whiteboard that I could get, okay, until the district until the district provides us with some better, whoops, let me fix that up here. Until the district provides us with some better teaching tools, which is actually, I think they ordered something for us, so I'm not gonna complain too much. Anyways, the air-fuel ratio, that's one of the corners. Another corner of this would be the compression, okay, compression. Okay, so the compression on this side, and again, I said this side, but it doesn't matter which side. By it being a triangle, they're equal, correct? Any geometry majors in here? Okay, so we have air-fuel ratio, compression, and then on this side, you can guess that, yeah, we have ignition, okay? We have ignition, or what we just simply call spark, right? Ignition or spark. So we have the air-fuel ratio, okay? We combine this into one because this, I call this the food, right? This is the food for the engine, the air-fuel ratio. And then we have the compression, okay? Which causes heat to occur and pressure. And then we have the ignition that lights that, okay? So all three of these have to be in good working order for this to achieve proper engine performance, okay? So what engine performance is, what this class does, okay, is teaches us how to check, okay? How to check, monitor, and diagnose these three areas, okay? Again, air-fuel ratio, compression, and ignition. Couple more things about air-fuel ratio, 14.7 to 1. What you might want to note down is that the air-fuel ratio, when it is at 14.7 to 1, which is considered perfect, okay? Like the perfect recipe, okay? It's called stoichiometric, okay? So that's, I'll write it down here. I can't spell it out loud, but if I write it, I can do it. Okay, so stoichiometric ratio. And that just means like the proper recipe, okay? So the proper recipe for a near perfect air-fuel ratio is 14.7 to 1, okay? So just like if you were gonna make some, I don't know, if you're watching a cookie show, let's say that Martha Stewart is gonna make some raisin cookies. Well, she needs like, you know, maybe a cup full of flour and a teaspoon of baking soda. Well, I don't know how to make cookies. So whatever it takes, okay? Anyways, whatever the recipe calls for, in this case, the recipe is 14.7 to 1. Again, 14 parts of air, 1 part of fuel by weight, always by weight, okay? Okay, so hopefully that kind of gives you an understanding, okay? We're gonna learn how to make sure that we have proper air-fuel ratio. We're gonna learn how to make sure we have proper compression, and we're gonna learn how to make sure we have proper ignition, okay? So what this entitles is that we learn, first of all, up here for the air-fuel ratio, that we learn about proper air induction. For the fuel, we'll need to learn fuel systems, okay? For compression, we need to learn about engine mechanical, valves, pistons, and rings, okay? All of the bottom portion, that what builds pressure in the compression chamber. And then finally for ignition, yes, we'll need to learn about ignition systems, right? We call this spark sometimes, okay? So we need to learn about ignition systems. We'll learn about all types of ignition systems that are on the market today, okay? So again, hopefully this gives you an idea of where we're gonna start. And let's go back to our regular screen. Let's get out of this one. And let's start with the lesson. Okay, so let's go back here and okay, so engine performance introduction. Here we go. So let's see. First, what I want you to do is I want you to start thinking about, and this is part of your worksheet. You need to write down and figure out the answer to this question, okay? And the question reads as follows. It says, what are the 3 ingredients required for proper combustion? Well, it's a spoiler alert, right? I already gave you that answer, okay? So you should know by now that the 3 ingredients required for proper combustion are fuel, okay? Oxygen, okay? And heat, okay? We need these 3 ingredients for proper combustion. We have to have enough fuel, and it has to be good, clean fuel, okay? The right amount of content for the vehicle, the right octane rating for the vehicle. Okay. Oxygen, of course, we have to have enough oxygen. It has to be in the proper air-fuel ratio as it reads here. Okay. And then, of course, heat. Heat is going to come from the from spark and the combustion process. Okay, so the proper ingredients for combustion are, three things are fuel, oxygen, and heat. Okay, that's what is required for combustion. Okay, let's move on. Okay, next we have, says what four requirements are required for creating engine power. Okay, so we had just combustion, okay, but what if we want to put some power behind that? Well, in order to produce power, we need to have the correct air-fuel mixture. We talked about that as well, right? The correct air-fuel mixture based on the year, engine size, the correct air-fuel mixture. Now, now keep in mind that even though the proper air-fuel mixture, okay, 14.7 to 1, that'll give us the best mixture. It is not necessarily the best mixture for your application. If you're, for example, if a vehicle has a high demand for fuel because it has a high horsepower engine, right, then you would probably want to run a little on the rich side, that is a little bit more fuel than is normally required. And on the other side, if you have a very economical vehicle, you can ride a little bit, you can run a little bit lean, that is a little bit more air. Okay, so the remember I said the 14.7 to 1, it's about what we want. Yeah, most of the time that's what we want. Going back to that, let me just remind you that 14.7 to 1 will deliver the greatest efficiency and the greatest amount of lowered emissions. Okay, which is very important, but it might not always provide the amount of power, okay, that the driver is wanting for that vehicle. Okay, so conditions for power are the correct air-fuel mixture, sufficient compression. Okay, you have to have sufficient compression based on factory pressure or percentage, depending on the OEM specification. We have to have good volumetric efficiency. Let's stop there for a second. What is volumetric efficiency? Well, volumetric efficiency is the proper amount of air coming in and coming out. Okay, you learned in engines class that the engine is simply a huge air pump, right? It is simply a huge air pump. The more air we're able to pump into the vehicle and the more air we're able to pump out of the vehicle will create the greatest amount of power, okay? You know this because when we have a artificially aspirated engine, think about that. What is that? Artificially aspirated engine. Yeah, you're right. An artificially aspirated engine is either turbocharged or supercharged, right? When we have an artificially aspirated engine, it produces more power, right? As a matter of fact, now what some manufacturers do for vehicles that produce very low power, they add turbos or superchargers to get that power up. But going back to volumetric efficiency, the more air we have coming in, the more air we have coming out, then that produces more power. Keep in mind that a non-turbocharged and a non-supercharged vehicle, or I'm sorry, engine would be called naturally aspirated, okay? Naturally aspirated, okay. And last we have adequate ignition and proper timing. So we have to have a good spark, okay, but it has to be at the correct time, okay? So these are our conditions for making power. These are conditions for making power. Okay. Let's move on. Okay. Next, we want to write down, okay, and you can start filling out your worksheets, okay, are the 4 requirements of a fuel system. This is going to stump some of you guys, okay? The 4 requirements of a fuel system. So what do we need on a fuel system? Think about that, right? Think about that for a second while I take a sip of water. Okay, so the 4 requirements of a fuel system are, you can guess one, I'm sure, is you got to have fuel in the tank, right? fuel is part of the fuel system, right? You gotta have fuel. Make sure that if you're diagnosing a vehicle that you have the proper amount of fuel and it is good fuel. When we get into fuels, we will teach you how to check fuels to make sure that they have the proper amount of, or don't have too much water and or alcohol in the system, okay? So fuel in the tank is a requirement. Next, we have to have a pressure differential. We have to have a pressure differential. Let's think about that for a second. Pressure differential. Well, the name implies that pressure differential, we have to have a difference of pressure from one point to the other. Think back in electrical class, right? Think back in electrical class. You have to have a difference of pressure, that is voltage, from one point to the other for the electrons to move, correct? Yes, that is correct. So at the battery, we have 12 volts, let's say. I know we have more than that, but let's just say it's a 12-volt system, so let's just keep it simple. We have 12 volts at the battery, and then we have what at ground? At ground, we have 0, or hopefully very, very close to 0. So that creates a pressure differential in the electrical system, okay? So that the electrons can move, right, from the positive to negative. Of course, that's the conventional theory. The electron theory states that electrons move from negative to positive, but that's okay. That's the automotive understanding is that they go positive to negative, and that's fine, right? The guys with the white lab coats, the engineers, those are the guys that think about it the other way, but that's fine. We're simple. We'll keep it positive, negative, okay? So our pressure differential, wow, I got off track there for a second. So pressure differential. What creates a pressure differential in a fuel system? Well, if you think about like a lawnmower or something simple like that, I know we're not here to fix lawnmowers. It's okay. So pressure differential in the fuel system. So in a lawnmower, as I was saying, it's simply gravity, right? Simply gravity. We put the fuel tank up high, and we let gravity feed down to the carburetor, right? So there's a pressure differential. But what about in an automotive system? What creates the pressure differential? Well, you might have guessed that the pressure differential is created by a pressure pump, right? So the pressure differential is created by a pressure pump. Typically on modern automobiles, it is mounted in the fuel tank, okay? And it simply creates pressure and pushes the fuel in upstream to the fuel rail and to the injectors and down into the cylinders, okay? So that's how the pressure differential is created in a fuel system. Next, we have the next requirement is that we take and we vaporize or atomize that fuel, right? Remember that liquid fuel will not burn, okay? Liquid fuel will not burn. It has to be either vaporized or atomized, and you can argue and say, well, it's the same thing, and it kind of is, right? When we think about vaporization or atomization, doesn't matter which one you want to say, it's fine. Think about a Windex bottle, right? When you spray a Windex bottle and that fine mist that comes out of the bottle, that is vaporization or atomization. Well, it starts as atomization, and as it is absorbed into the environment, then it becomes vaporized, right? So atomization would be like the fine mist that comes out, and as it evaporates, there's a name, evaporates, it vaporizes, okay, it vaporizes. So that has to happen. Where does that happen? Where does that happen? Where does the vaporization or atomization happen? Think about that for a second, okay? If you guessed that it happens at the fuel injector, you are correct. That's exactly where it happens, okay? Happens at the fuel injector. So those are 3 things that are required. So what else are we looking at? We're looking at, yes, we have to have cleanliness, quality, and proper octane. Okay, so those 4 things. And the 4th one is a little redundant, right? Because you can argue and say, well, isn't that what we talked about in the fuel? Yeah, but we have to have fuel, but it also has to be clean, and it has to be good quality fuel and octane. Today, we talk about upper tier gasoline, right? And if you look that up, you'll be surprised some of the gas stations that are considered the upper tier gasoline. You know, you don't want to get your fuel at, you know, some drive-through liquor store, you know, that sells, you know, bait and tackle, is a deli and sells gasoline out the back. You know, you want to get good quality fuel. And no, not all fuels are the same. Sorry to burst your bubble or get that theory, that myth going. No, not all fuel is the same, okay? Yes, many of the fuels are produced at the same refineries, but when they are transported in, the additives that are added at the refinery are different, okay? Nobody sees that, okay? Nobody sees that, but trust me, if you drive a vehicle that requires good quality, high octane fuel, okay, and you pump it at one station, say like a 76, which is very, very good gasoline, Chevron, you know, Shell, gas stations of that nature, and then you go and get some very, very cheap fuel, okay, some non-name brand, you'll notice a difference, okay? You will notice the difference. And by the way, let me just tell you this. If your vehicle does not require high octane, then you don't need to be buying high octane, okay? The only reason that you need high octane fuel is if your vehicle requires it because it is a high compression vehicle, or because maybe you've altered your vehicle, okay? If you've altered your vehicle and now you require higher octane, then that would be another reason. Higher octane fuel will not make your vehicle pass smog. So all those urban myths, okay, can be dismissed, okay? Please don't be one of those people. Thank you. Okay, moving on. Okay, keeping on. Next we have the 5 requirements of an ignition system. 5 requirements of an ignition system. And after this section, we'll stop. I'm going to stop for a quick break, and that'll be the end of video part 1, okay, or a recorded lecture part 1, and then we'll move on to the second portion. Okay, so please hang with me. Of course, you guys can stop and go at any time you want, but let's explore this next topic, which is, again, what are the 5 requirements of an ignition system? Okay, this is an area that many people are weak on, and don't feel like I'm talking about you. I'm talking about the automotive industry, period. Okay, one of the areas is the ignition system. Okay, many times in the ignition system, if we guess at it, right? Like, let's say if we find that there's a defect in the ignition system, I've heard technicians, and I'm talking technicians with 20 years of experience, say, oh, the distributor is defective. Okay, and I'm talking about distributors. That's an older technology, I know, but I hear technicians talk about, oh, the distributor is defective. Well, the distributor itself is simply a housing that houses many components, okay? If you're gonna say, oh, the distributor is faulty, well, then now you're talking about an ignition module, you're talking about a pickup coil, you're talking about an igniter, you're talking about several different components that are housed within the ignition system. So what I'm trying to say, if you're guessing that it's the distributor, that's exactly what you're doing. You're guessing, you're not diagnosing a thing, okay? Even if you're gonna replace a distributor, because sometimes it's more effective to simply buy the entire distributor, as a technician, you should, I hope you do, have enough curiosity where you wanna say, well, I wanna figure which part of this is defective, okay? And you will learn that in this class, okay? So what are the 5 requirements for an ignition system? Okay, take a second to think about that. Some of them are very basic. There's 3 specific components of an ignition system that all ignition systems have. And we'll talk about those in a second, but let's talk about what are the 5 requirements of an ignition system, okay? So the 5 requirements are, one is you have to have the correct supply voltage, okay? You have to have the correct supply voltage. That is the amount of voltage getting to the ignition system. Let me stop there for a second because this is important. I want you guys to know this right off the bat, okay? And I'm gonna go ahead and stop that, and I'm going to share my screen. And I'm going back to my whiteboard here, share. And let me see here. Okay, so let's look here. What we mean by the correct voltage, okay, is, and this is new to me, guys, so give me a second here. Like that, and then I know if I do like this, and if I go like this, ta-da, okay. So let's say that we're looking at a coil, okay, and our coil looks like, and I'm going to draw an old school bottle coil, okay? So all coils have a positive and a negative. All coils, I don't care if it's a one coil system, a two coil system, whatever it is. What the proper voltage is this. It means that simply you got to have your 12 volts going to your positive side. Of course, the negative is going to go actually to a type of switch. Don't worry, we'll talk about that in ignition systems. But what they mean is 12 volts going to the proper side of the coil. Okay, at all times. That means during key on, engine off. That means during engine cranking, and that means during engine running. Again, it means 12 volts, key on, engine off. Okay, key on, engine cranking, and key on, engine running. Make sure you're familiar with these three little acronyms. Okay, key on, engine off. Key on, engine cranking, key on, engine running, okay? So during these three times, we have to have our 12 volts, okay? And I just wanted to make sure you guys understood that portion of it because it's very, very important. So let me, once again, stop my share here and work my way back to my presentation. And I was here. Okay, so requirements of the ignition system are correct supply voltage, okay, just talked about that. The high voltage spark. So we have to be able to create a high voltage spark, okay? Today's ignition systems easily can produce 40,000 volts, okay? Back in when ignition systems were at the beginning of even at the beginning of electronic ignition, we're only looking at about 10 to 12,000, okay? Now we're looking at 40,000 plus easily. So we have to produce a high voltage spark. We have to have the correct cylinder, okay? So it has to happen at the correct cylinder, okay? And it has to happen at the correct time, And it has to be of the correct duration, okay? Correct duration. Go back to those, okay? So those are our 5 requirements there, okay? And like I said, like I promised, we're going to stop there for a second. And I'm going to stop here, take a little bit of a break. You guys can hopefully work on your worksheets a little bit, okay? And then we'll come back and look at the next section of video. And with that, I'm going to stop my recording and stop this. Oops. All right, see you in a bit.